discuss about compass surveying. Now, first we have to understand what is compass surveying. Compass surveying means a specific survey work where we will use compass as a surveying instrument. Like you have used chain in chain surveying, same procedure. Here we will use compass in case of chain. Now, you may ask why chain surveying is why we use compass surveying instead of chain surveying? Because some specific ground where the ground is too large, undulating and overcrowded, then triangulation, that is the basic principle of chain surveying, is not possible. Therefore, we have to go through a new method. Now, what do you mean by traversing? Traversing means to enclose an area with some straight line. Maybe, suppose, say this is a pond. This is a pond, and we have to enclose the area of pond using some straight line. How can we do that? Say we have started from this point, and let's change a different color. This one, 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 and this one. Look, here we have enclosed the whole area using some straight line, and we here the starting point and ending point of the traverse are same. Now, what will happen? Here, it is known as closed traverse. Let me tell you first. Why closed traverse? Because the starting point and ending point are same. Now, if we are considering a shoreline of a river, say the river is flowing in this way. And we have to enclose at least we have to mark the shoreline using some straight line. Here the initial point will not merge or not coincide. Therefore, say we are using to enclose the area in this way. In this way, we can enclose the surface. Here, this is the starting point and this is the ending point, and they are different and they are not meet each other. Therefore, this will be treated as open traverse. So this one is as closed traverse and this one is as open traverse. Okay, so this is the basic principle of compass surveying, that is traversing. Now, I think you have got the clear idea about traversing. Now let's discuss about bearing. Before compass surveying, let me tell you one thing. This, in case of closed traverse, let's take a fresh diagram. Let's take a fresh diagram. This is, say you have enclosed the area using the straight line where you have taken A, B, C, D and E. Okay, and here as it is a closed traverse, therefore the starting point and ending point are same. Now, what will happen? You may discuss this thing as it's a shape in the shape of regular pentagon. Now, what will happen? What we are thinking or what we are discussing here, that is the length of each line, that is the line of AB, BC, CD, DE and EA. We are concerned about this line, length of the line. Okay, in case of traversing, we need these documents. Next, we have to know the value of the interior angle, this value, this value, this value, this value, and this value. Therefore we need angle A, B, C, D, and E. Look, you have to understand one thing in a clear way, that is, if I haven't written the angle of BAE, I have just written angle A or angle B, angle C in this way. Why? Because in case of a closed traverse, or in this angle is treated as interior angle, int angle, and if we are considering this angle, this will be treated as exterior angle. Clear? But in geometry there is a small difference. What happened in case of geometry? In case of geometry, suppose this is a straight line, and this is an angle. Say this is a triangle. Let's take this triangle. So this will be the interior angle, and this will be the exterior angle. Therefore, in case of geometry, interior angle plus exterior angle will be 180 degree, whereas in case of surveying, the summation of interior angle plus exterior angle will be 180. In case of, let's change the color. In surveying, interior angle plus exterior angle will be 360. This is the main difference. Yeah. Okay. Now we have to understand then what is the basic principle of compass surveying, that is traversing. And what is the specialty in case of traversing? Traversing is to enclose an area in terms of straight line. It may be you can say it may be a closed traverse or it may be a open traverse, but what you have to consider, that is the length of the line, that is here the ABBCCDDEA, length of this line. This data is very important. And the angle, that is angle BAE, AED, EDC, DCB, and CB in this way. Now let's discuss about the angle. I have told you that the term angle. What do you mean by angle? Angle is if two straight line cross each other, then therefore these are known as angles. Now in case of surveying, we will use the term bearing instead of angle. What do you mean by bearing? Same, bearing is same as angle, but difference is that in case of geometry we will use the term angle, in case of surveying you will use the term bearing. Therefore bearing is nothing but the angle. Clear? In case of surveying we will use the term bearing, not angle. Clear? Now let's discuss about different types of bearing. Bearing may be different types. Suppose if you are talking about a straight line, or if you are talking about a traversing, close traversing, there may be full circle bearing. There may be two types of bearing, that is, you may say four bearing. Suppose this is a line. Suppose this is a line and this is next line. So what will happen if, let's give a name A, B, C. Let's, and if AB, if we increase the line AB, then what will happen? It will increase in this way. Now this angle is known as deflection angle. This angle is known as deflection angle. Clear? And this angle is known as interior angle, interior B, and this is known as exterior B. Clear? Exterior B. This is clear. I think this is clear to you. Let's erase something so that we can add some more thing here. Okay, say this is the continuation of the line. Actually, we don't need the continuation of the line here. What is required, this is our B point, and the surveying, the direction of the survey, that is, we are moving from point A to point B to point C in this way. Therefore, this is your front side, this should be your front side, and this is your back side, this should be your back side. And if this is your front side, therefore the bearing in this way, I mean in front way, the bearing will be known as fore bearing. Here I haven't mentioned the term bearing, I have just written it because there is another concept you need to grow. Therefore, just watch. This is fore bearing, and if the direction is backward, if the direction of the surveying is in different way, as we are moving from A to B, we are moving from A to B, B to C in this way. Therefore, fore bearing will be A. Clear? Suppose we are considering the line AB. Therefore, fore bearing will be at A. At A. Now, the same bearing, same line, the bearing should be also same. No, there is a small difference. Let's discuss about a new type of some bearing, that is, I have told you already, that is angle is nothing but the bearing. Let's talk about some different types of bearing. Say one is whole circle bearing, WCB. In short, it is the full form of whole circle bearing. Clear? Whole circle bearing. What do you mean by whole circle bearing? When we are measuring an angle and the value of the measurement lies in between 0 to 360 degree, then we may consider the bearing as whole circle bearing. Now, how the angles are measured in case of surveying? In case of geometry, what we will do? In case of geometry, we use this horizontal line to measure the value of angle, any angle. But in case of surveying, there is no position of the horizontal angle. We will use the magnetic north. Before magnetic north, you need to know what is true north. So before starting, we have to understand what is bearing. Bearing means angle, I have told you. But in geometry, what is your reference line? That is, you are going to draw your angle with reference to a horizontal line. But in case of surveying, what is the horizontal line there? Nothing. But in surveying, we will use a fixed line, that is magnetic north. What happened actually? Let's discuss it in a different way. You have seen a magnet, needle magnet, or any magnet. It's a basic property of showing north and south direction. If we are getting north and south direction in any point, any location, any station in field, we may measure the angle using that magnetic north. Clear? Using that magnetic north, we can measure the angle between between the angle and the magnetic north. What I am talking about, let's see here. Suppose in case of surveying, what will happen? Say this is your traverse. This is your traverse. Let's take a very prominent one. Okay. Say this is your traverse. Now, what we want to know, we want to measure these angles. What will happen? Or take a different one. Suppose we are considering a straight line, and we want to measure the angles with respect to the magnetic north. As magnetic north is a fixed line, each and every location the magnetic north will be a fixed line, na? Therefore, say this one is our magnetic north, and as this is magnetic north, it's a parallel line. So this line and this line will be parallel in each and every point. Now we are getting here two angles. One is this one and another one is this one. This one will be the angle we have measured in, say, now here this magnetic north line is the reference. Clear? Here the magnetic north line is the reference line. We are going to measure the angle with reference to this magnetic north in each and every point. Now this angle is measured from the magnetic north in the direction of, actually in clockwise direction, and this angle is measured according to anti-clockwise direction. Now which one is correct? Let me tell you one thing very clearly. Whenever you are going to measure an angle with respect to magnetic north, in case of whole circle bearing, you have to move in clockwise direction always. Keep this thing in mind. In clockwise direction always. So this one is the correct answer. This one is our required bearing. And as the direction of surveying is in this way, therefore this is the foresight of the, what do you mean by foresight? This is the, front side of the line. Therefore this angle will be renamed as forward bearing. Now see, same line AB, same line. We are measuring the angle at. Now what will happen? And if we are moving from B to A, this will be the back side. We are moving backward. So if the angle is measured in this way, I have told you that is you have to move only clockwise movement. Therefore if we are going to measure the angle in this way, this will be the back bearing. This will be treated as back bearing. Now as these two lines are parallel, therefore this angle, let's change the color, this angle and this angle, what will be the sum of these two angles? What is the difference of this angle? Sorry, what will be the difference between these two angles? Let's see. If we are increasing the line in this way, therefore this is the angle of same angle of forward bearing. What is the difference? This will be the difference. See, this is a straight line, na? Therefore, the difference between forward bearing and back bearing will be 180 degree. Clear? Always it is true for each and every point on earth. What will be the difference between forward bearing and back bearing? That will be 180. It's fixed. As we are talking about whole circle bearing. Now I have told you there are different types of bearing. You can say another bearing is reduced bearing or quadrantal bearing. Let's talk about quadrantal bearing. What do you mean by quadrantal bearing? Same thing. It is denoted as QB. That was denoted in WCB. This is denoted by QT. Achha. Quadrantal bearing is slightly different from whole circle bearing. What is the difference? Here we are taking not only north, also south, also east, also west. So north, south, east, west we are taking. What will happen? Let's see. Suppose the same angle, this line AB. Okay, just draw here the line AB. This is our line AB. This is the point A, and say here we are getting the line B. Here. Now this is our forward bearing, but in case of back bearing, what will happen? Let's draw here. This is our north, this is our south, this is our east, this is our west. Now here, in case of whole circle bearing, we are measuring any line with respect to north only. There is no east, no south, no west. But in case of whole circle bearing, what will happen? We have to measure the angle with respect to either north or south with the help of east and west. What do you mean by north or south with the help of east and west? We are measuring the angle in this way. Suppose this is our B line, B point. Therefore, we are going to measure this angle. I mean, this is the line, so we have to measure the angle. Here, see, south is nearer to the line. Therefore, we are measuring the line with respect to south. Clear? We are measuring the line with respect to south. This is, we are measuring the line with respect to north. Here, we are measuring the line with respect to south, as the line is nearer to south. Is that clear to you? Now what will happen? See, this is our east side and this is our west side. This line AB is close to the west side, so we have to measure the line with respect to west line with the help of west line. What do you mean by with the help of west line? We will measure the line with the help of west side. What do you mean by west side? See, here the angle is, say, this is as 60 degree. Now what will happen? You are talking about a angle, I'm sorry, bearing, that is 60 degree, south 60 degree. Now how can we draw the line? This is our south line, 60 degree. This is our 60 degree. Wait, this is not only 60 degree, this may be 60 degree also. Therefore this angle may be 60 degree. Oh sorry, we are measuring the angle with respect to south or north only. So this may be south 60 degree, this may be 60 degree. Difference is that it is 60 degree south, and this direction is west and this direction is east. Therefore this is south 60 degree west and this is south 60 degree east. This is the only difference here. This is the only difference mentioned here. Here, so here what will be the angle? That is south 60 degree west. Is that clear to you? South 60 degree west. Is that clear to you? Okay. This is the difference between whole circle bearing and quadrantal bearing. In case of whole circle bearing, what will happen? Whole circle bearing, we are measuring the angle with respect to the north line only. But in case of quadrantal bearing, we are measuring the line with respect to north and south line and with the help of east and west line. Okay, now I think you have understood the difference between whole circle bearing and quadrantal bearing, forward bearing and back bearing. I think it's clear now. Okay, now let's discuss about a new type of bearing, that is reduced bearing. What do you mean by reduced bearing? Nothing. Suppose this is a whole circle bearing, the value is say line AB. We are going to write in this way, line AB, whole circle bearing is 45 degree. In case of whole circle bearing, you don't need any type of say east, west, south. You don't have to mention anything, because whole circle bearing, the reference line will be the magnetic north only. What will happen? What you will do to get a detail about AB line? This is your magnetic north, okay, and here with magnetic north you are going to say this is your 45 degree, 190 degree, and this is your 45 degree. So this is your AB line whose whole circle bearing is 45 degree. Now if you are going to discuss this line in case of say quadrantal bearing, what you are going to write? First, it's in the north zone or south zone? North zone. Okay, just write down. Now it's in the east zone or west zone? East zone. Therefore what you will write? You will write north 45 degree east. What will happen if you write down that north 45 degree west? What will happen? North 45 degree west, it is a quadrantal bearing or reduced bearing. It is a reduced bearing, say. So what will happen? Take magnetic north as it is mentioned here, north. Therefore 45 degree in the west side. This is your 45 degree. See, here we are taking the angle in anti-clockwise direction. Why? Because we are measuring the line with respect to north or with respect to south. If we are measuring the line with respect to north or south, therefore we have to measure the line with respect to north. If it is on eastern side, we will take clockwise direction. If it is in the western side, west side, then you have to take anti-clockwise direction. Same for the south section. If it is in case of south, if you are taking the angle in the eastern side, then you have to move in anti-clockwise direction, and if you are taking the direction in west side, then you have to take it in clockwise direction. Clear? So what is the difference between quadrantal bearing and reduced bearing? Quadrantal bearing is measured in surveyor compass. I am just talking about a new term. You will understand later what is surveyor compass and what is prismatic compass. Let's just learn the thing, that is quadrantal bearing is measured in surveyor compass, and reduced bearing is converted from whole circle bearing. Clear? Okay. Let's discuss about a new thing, that is meridian. Okay, here we are going to discuss about some specific definition, that is one is meridian. What do you mean by meridian? There is different types of meridian. We are discussing true meridian first. True meridian. Before starting this meridian concept, I just want to draw a picture of Earth. Suppose this is our Earth. Let's take it. This is our Earth. Clear? And this is the axis of our Earth. Clear? This is the axis. Now what will happen? Okay, now let's take a different color. Actually, this is our true north and this is our true south. Geographical north and geographical south. Now let's discuss about what happened if you hang a needle. The needle will show you the direction of true magnetic north and magnetic south. What we are discussing here, we have considered that a large magnet is placed inside the earth in this way. Let's take a clear picture. This way. It is placed inside the earth. Therefore, the axis of this line, say this one, is the magnetic north and magnetic south. Clear? Now these true meridian, what do you mean by true meridian? The line or plane passing through the geographical north pole and geographical south pole and any point on the surface of the earth is known as true meridian. And in case of magnetic meridian is when a magnetic needle is suspended freely, then it indicates a direction, that is magnetic north. You know that very well. A line between these magnetic north and the line itself is known as the magnetic bearing of that line. Clear? Therefore, what do you mean by magnetic meridian? That is the line joining magnetic north and magnetic south. And what do you mean by true meridian? That the line joining geographical north pole and geographical south pole and any point on the surface of the earth. This is known as magnetic true meridian, and it is known as magnetic meridian. I think this is clear to you. Now, why this is most important thing? See, there is an angle between true meridian and magnetic meridian. Now, let's draw another diagram. Suppose this is our true meridian. Say this is our true meridian. As you can see that true meridian and magnetic meridian are not same. There is an angle. Therefore, say this is our true meridian. This is our magnetic meridian, say. And what we are doing, we are taking magnetic meridian as a north. So let's rotate the picture in such a way that it becomes the magnetic meridian as north. This is our magnet. this is our magnetic meridian. And if we are taking a line in this way, let's change the color of the line. So this one. Now what will happen? See, this is our line AB. This is our line AB. Now the angle between true meridian and the line, this is known as true bearing. True bearing. Clear? And the angle between magnetic meridian and the line is known as magnetic bearing. Is that clear to you? True bearing and magnetic bearing. This is the difference. True bearing is the line between true meridian and the line itself, and magnetic bearing is the line as the angle between magnetic bearing and magnetic meridian and the line itself. Clear? Now sometimes what happens, actually when we are using some, say, theodolite, there we have to assume a meridian. This may be treated as arbitrary meridian. Clear? Arbitrary meridian is nothing but when we are assuming a meridian in case of ease of work, when we are using total station, then we are using this arbitrary meridian as a instead of magnetic meridian or true meridian. Therefore this arbitrary meridian is something that is same as arbitrary benchmark you have written. You have I think you know earlier. Now what is grid meridian? Sometimes for preparing a map, some state agencies specially, they use some several parallel lines to the true meridian for a particular zone. These are known as grid meridian. There's nothing else, but nothing different like arbitrary meridian, like grid meridian. Okay? Now I have discussed already whole circle bearing and magnetic bearing. I think this one is also clear to you. Let's discuss about magnetic declination and dip of magnetic needle. Let's discuss about a new topic, that is local attraction. What do you mean by local attraction? I have told you earlier that if you are taking a straight line, say this is our AB line and this is our magnetic north, and this is our magnetic north here. Now here the thing occurs. This is magnetic north. I am just writing here north and I am here writing north. What will happen? I have told you that the angle between magnetic north and the front side of that line, this angle is known as forebearing. What do you mean by, what do you know? This is as forebearing, front side forebearing, and the back portion of the line, that is this line, this angle is known as back bearing, that is BB. Forebearing, back bearing, clear? Now what will happen? Difference between these two lines is always 180 degree. How? I have shown it earlier. The difference between back bearing and forebearing is always 180 degree. Now if let's consider if a magnetic substance is present in this zone. This is a, consider that this is a source of magnetic ore, metallic ore, especially iron ore, mines of iron ore, or a very high tension line is laid under the ground where you are performing your survey. What will happen? Here the north sign will be deflected slightly. towards the direction of the magnetic substance. It's quite obvious things. So let's deflect the line. What will happen? This will deflect in this way. Now what will happen? This whole angle becomes your back bearing. Here you can see these two lines are not parallel. If they are not parallel, then the difference between back bearing and forward bearing will not be 180 degree. This phenomena is known as the local attraction. In case of local attraction, the difference between back bearing and forward bearing will not 180 degree. Clear? Different types of problems are asked into mentioning the term local attraction. Local attraction is a very important part and very simple part also. Suppose you know the north section, this A point is free from local attraction. Suppose, therefore you can assume that this forward bearing is correct, this forward bearing is correct, and one thing you know that the difference between forward bearing and back bearing is always 180 degree. So you can easily calculate the value of back bearing from this value. It is possible. Therefore local attraction value can be calculated using this phenomena, but it should be mentioned that is station A is free from local attraction. Now what happen if in case of a problem you may find that a specific line, the difference between forward bearing and back bearing of that line is 180 degree. Therefore you can conclude that the starting and ending point of that line is free from local attraction. Clear? From that points you have to calculate other bearings. This is the method for local attraction related problems. Very easy. I'll show it to you later. Next we are going to discuss about different types of declination. What do you mean by declination? I have shown it to you already. The horizontal angle between the magnetic meridian and true meridian is known as magnetic declination. This is the magnetic declination. Clear? If the declination is towards east with respect to true north, keep this thing in mind. If the declination is in eastern side, it will be known as declination east, and if it is in the western side, then it will be known as declination west. Suppose it is placed in this way, the magnetic meridian is placed in this way. Say this is the magnetic meridian in some place. Therefore this declination will be treated as declination west. Clear? This declination will be treated as declination east, and this will be treated as declination west. And this magnetic declination is not fixed for a particular place. This is a simply like pendulum. They behave like a pendulum. Some a specific place where the declination is right now, the declination is 5 degree east. After 100 years or after say 200 years, you may find out that the declination becomes maybe 10 degree west. It is possible because it's a you may consider this thing as a pendulum. There is a very small value. It may change in case of annual variation. If you are considering about annual variation, if some natural disturbance occurs, then this variation becomes irregular. Therefore it will be treated as, it will be known as irregular variation. Clear? Now suppose we are marking the points of equal declination on the earth. Therefore the line joining these equal declination points will be known as isogonic line. Here, isogonic line. and the line joining through the zero declination will be known as agonic line. Clear? These are just for your knowledge. Some short question may be asked regarding this. And you know one thing, that is dip. What will happen? Suppose you have taken a material that will be changed into magnet. Before magnetized, point out the CG, place a hole. If you place the material through the CG point, the material will be perpendicular, horizontal. But after magnetized, you may see that the material is not horizontal at all. It may be inclined in such a way, one portion, one pole of the magnet is somehow slightly downward and other part is upward. This phenomena is known as the magnetic dip of magnetic needle. The angle between the horizontal line and the magnet, inclined magnet actually, this angle is known as dip of the magnetic needle. What I am talking about actually, suppose you have taken a material in this way. Before magnetized, this is your CG. You have placed a ring and you have hanged it in this way. After magnetized, what you may find that this may be in this way. Therefore, the angle say this is the axis of the magnet and this is the horizontal line. Clear? This angle is dip. Clear? This is the dip. The value of dip at the equator is always 0. Keep this thing in mind. The value of the dip is 0 at equator and 90 degree in case of pole, north pole or south pole. Clear? So these are the basics of compass surveying.